Hello, my dear students. In the previous video, we have learned the relation between the zeros and coefficients of a linear polynomial, quadratic polynomial, and a cubic polynomial. In today's class, we are going to solve few questions based on the relationship between the zeros and coefficients of a quadratic polynomial. Once again, I welcome you all to your own channel, Noble Mathematics. We'll find a way or make one. Today's first question is, if alpha and beta are the zeros of a quadratic polynomial, f of x is equal to x square minus 5x plus 4, find the value of 1 by alpha plus 1 by beta minus 2 alpha beta. So here we are given a quadratic polynomial f of x is equal to x square minus 5x plus 4, and alpha and beta are the zeros of this quadratic polynomial. We have to evaluate 1 by alpha plus 1 by beta minus 2 alpha beta. Here, to find the value of this expression, we will use the relation between the zeros and the coefficients of a quadratic polynomial. We know that if alpha and beta are the zeros of any quadratic polynomial, which is in the standard form, that is ax square plus bx plus c, then the sum of the zeros, that is alpha plus beta, is given by minus b by a, and the product of zeros, alpha beta, is equal to c by a. Comparing this quadratic polynomial with the standard form, we have a is equal to 1, b is equal to minus 5, and c is equal to 4. First of all, we will find the values of alpha plus beta and alpha into beta. Then we will convert this expression in terms of alpha plus beta and alpha into beta using suitable algebraic identities. So here, first of all, we are going to find if alpha and beta are the zeros of this quadratic polynomial, then what is the value of alpha plus beta and alpha into beta? Then we will convert the expression 1 by alpha plus 1 by beta minus 2 alpha beta in terms of alpha plus beta and alpha into beta. Look at the solution. Given f of x is equal to x square minus 5x plus 4. According to question, alpha and beta are the zeros of the polynomial f of x. Therefore, comparing to the standard form of the quadratic polynomial, a is equal to 1, that is the coefficient of x square, b is equal to minus 5, that is the coefficient of x, and c is equal to 4. We know the relation between the zeros and coefficients of a quadratic polynomial. Based on the relation, we have alpha plus beta, that is sum of zeros, is equal to minus b by a, that is equal to minus of minus 5. Here the value of b is minus 5, divided by a is 1. Minus of minus 5 is 5 by 1, that is 5. Then the product of zeros, alpha beta, is equal to c by a. Here the value of c is 4 by the value of a is 1. 4 by 1 is equal to 4. So we have the values of alpha plus beta and alpha beta. We have to find the value of the expression 1 by alpha plus 1 by beta minus 2 alpha beta. To find the value of this expression, we have to simplify this expression and convert it into the form of alpha plus beta and alpha beta only. So this expression is going to be simplified by using the LCM. The LCM of alpha and beta is alpha beta. Multiplying this alpha beta with the 1 by alpha, we get a beta plus alpha beta into 1 by beta, we get alpha minus alpha beta into 2 alpha beta, that is 2 alpha beta into alpha beta. Here the LCM is multiplied with each term of the expression. Beta plus alpha is alpha plus beta minus 2 into alpha alpha square, beta into beta, beta square, whole divided by alpha beta. Here alpha plus beta has not changed because we have the value of alpha plus beta, minus 2 alpha square beta square can be written as 2 alpha into beta the whole square divided by alpha beta. Here the denominator also has no change. Now this expression is expressed in the form of only alpha beta and alpha plus beta. Here we are going to substitute the values of alpha plus beta and alpha beta. By the relation, we have alpha plus beta is equal to 5. So alpha plus beta is equal to 5 minus 2 into alpha beta square. Alpha beta is 4. So 4 square divided by again alpha beta, that is 4, is equal to 5 minus 2 into 4 square 16 whole divided by 4, that is equal to 5 minus 2 into 16, 32 whole divided by 4. 5 minus 32 is minus 27 divided by 4. Therefore, the value of 1 by alpha plus 1 by beta minus 2 alpha beta is equal to minus 27 by 4. Look at the second question. If alpha and beta are the zeros of the quadratic polynomial, f of x is equal to ax square plus bx plus c, then find the value of alpha raised to 4 plus beta raised to 4. In this question, you are given a quadratic polynomial which is in the standard form itself, and alpha and beta are the zeros. We have to find the values of alpha raised to 4 plus beta raised to 4. By using the relation between the zeros and the coefficients of a quadratic polynomial, we can write the values of alpha plus beta and alpha beta. And now we will convert the expression alpha raised to 4 plus beta raised to 4 in terms of alpha plus beta and alpha into beta. Given alpha and beta are the zeros of polynomial f of x is equal to ax square plus bx plus c. If alpha and beta are the zeros of the polynomial f of x is equal to ax square plus bx plus c, therefore alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. So here the values of alpha plus beta and alpha beta are in terms of a, b and c only. Using the values of alpha plus beta and alpha into beta, we have to find the values of alpha raised to 4 plus beta raised to 4. For that, we will convert the expression alpha raised to 4 plus beta raised to 4 in terms of alpha plus beta and alpha beta. For that, we will use some suitable algebraic identities. Now, alpha raised to 4 plus beta raised to 4 can be written as alpha square the whole square plus beta square the whole square. And now I will add 2 alpha square beta square, and to balance I subtract 2 alpha square beta square. Why I did so? As a result, I am getting this expression in the form of a square plus b square plus 2ab, which is a plus b the whole square. In place of a we have alpha square, and in place of b we have beta square. So this expression can be written as alpha square plus beta square the whole square. Alpha square plus beta square the whole square. If you use the identity a plus b the whole square, you will get alpha square the whole square plus beta square the whole square plus 2 alpha square beta square. So to complete this expression as a perfect square, that is a plus b the whole square, I added here 2 alpha square beta square, and to balance I subtracted alpha square 2 alpha square beta square minus 2 alpha square beta square. Again we have here alpha square plus beta square. We have the values of only alpha plus beta and alpha beta. So again we have to convert alpha square plus beta square in terms of alpha plus beta and alpha beta. Alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta the whole square minus 2 alpha square beta square. There may be some confusion about this relation. Here alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta. I will explain here. Alpha plus beta the whole square minus 2 alpha beta. If you expand this by using a plus b the whole square, we get alpha square plus beta square plus 2 alpha beta, then minus 2 alpha beta. Now you can see plus 2 alpha beta and minus 2 alpha beta will be cancelled. Then what is left? Alpha square plus beta square. So we can write alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta the minus 2 alpha beta the whole square. This is the power 2 written here, and minus 2 alpha square beta square. Look at this step. The expression alpha raised to 4 plus beta raised to 4 has been converted into the terms of only alpha plus beta and alpha beta. Here, in place of alpha plus beta, I can write minus b by a the whole square minus. In place of alpha beta, I can write 2 into c by a the whole square minus alpha square beta square can be written as 2 alpha beta the whole square. Now minus b by a the whole square is b square by a square minus 2 into c by a the whole square minus 2 alpha beta is again c by a the whole square. We have to simplify this expression. This is whole square. First of all, we will find out the LCM of these two terms. So we get is equal to the LCM of a square and a is a square, and here if you multiply this term with the LCM we get b square minus, here if you multiply by a square we get a 2ca the whole square minus, here again we have a 2c square by a square. C by a the whole square is c square by a square. As this is a whole square, we can take the square of the numerator and denominator separately. We get a b square minus 2ca the whole square divided by a square the whole square is a raised to 4 minus here 2c square by a square. Now we have two terms. I take the LCM of the two terms. The LCM of a raised to 4 and a square is again a raised to 4. So a raised to 4 is the denominator. If you multiply this term with the LCM, a raised to 4 and a raised to 4 will be cancelled, and we will have only b square minus 2ca the whole square minus, if you multiply this LCM here, a raised to 4 and a square will be cancelled and a square will be left in the numerator. So this will become 2c square a square. So the final answer is b square minus 2ca the whole square divided by minus 2c square a square whole divided by a raised to 4. That is, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then the value of alpha raised to 4 plus beta raised to 4 is equal to b square minus 2ca the whole square minus 2c square a square whole divided by a raised to 4. Now we are going to see another type of question. If alpha and beta are the zeros of the polynomial f of x is equal to x square minus 3x minus 2, find a quadratic polynomial whose zeros are 1 by 2 alpha plus beta and 1 by 2 beta plus alpha. In this question, you are given a polynomial and also it is given that alpha and beta are the zeros of that polynomial. And we have to find a second polynomial, that is another polynomial whose zeros are 1 by 2 alpha plus beta and 1 by 2 beta plus alpha. Here we have to do in two steps. First one, for the given polynomial, if alpha and beta are the zeros, what is alpha plus beta and what is alpha into beta? So let us go with the finding the values of alpha plus beta and alpha into beta from the given polynomial. For the given polynomial, f of x is equal to x square minus 3x minus 2, alpha and beta are the zeros. Therefore, alpha plus beta is equal to minus 3 by a, which is equal to, comparing the standard form of a quadratic polynomial, the value of b is minus 3. So minus of minus 3 by the value of a is that is the coefficient of x square 1. So minus of minus 3 by 1, that is equal to minus of minus plus 3 by 1 3. Alpha into beta is equal to c by a. C means the constant term which is minus 2 by coefficient of x square, that is 1, that is equal to minus 2. So alpha plus beta is equal to 3 and alpha into beta is minus 2. Now for the required polynomial, the two zeros are given 1 by 2 alpha plus beta and 1 by 2 beta plus alpha. For the required polynomial, zeros are 1 by 2 alpha plus beta and 1 by 2 beta plus alpha. Therefore, what is the sum of these two zeros? Let the sum be denoted by s. S is equal to 1 by 2 alpha plus beta plus 1 by 2 beta plus alpha. Because to write a quadratic polynomial, we need the sum of the zeros. For that, we just add this as if these two are two fractions. So here the LCM is 2 alpha plus beta into 2 beta plus alpha. Here this will be multiplied here 2 beta plus alpha plus this will be multiplied here 2 alpha plus beta is equal to alpha plus 2 alpha we get 3 alpha plus 2 beta plus beta we get 3 beta. The numerator is simplified. And now we have to multiply here 2 alpha into beta, 2 alpha into 2 beta, that is 4 alpha beta plus 2 alpha into alpha, that is 2 alpha square, plus beta into 2 beta, that is 2 beta square, plus beta into alpha, that is alpha beta. From 3 alpha plus 3 beta, you can take 3 common. So it is equal to 3 into alpha plus beta whole divided by. Here you can see we have 2 alpha square plus 2 beta square plus 4 alpha plus alpha beta, that is 4 alpha beta plus alpha beta is 5 alpha beta. So this becomes 3 into alpha plus beta divided by. From these two terms we can take a 2 common, the 2 into alpha square plus beta square plus 5 alpha beta. You know what is the expression alpha square plus beta square in terms of alpha plus beta and alpha beta. So on substituting that value, that is numerator has not changed, 3 into alpha plus beta. In the denominator we have 2 into. What is alpha square plus beta square? Alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta plus 5 alpha beta. Alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta plus 5 alpha beta. Again we open the bracket. Numerator has not changed. 3 into alpha plus beta divided by 2 into alpha plus beta the whole square minus 2 into 2, 4 alpha beta plus 5 alpha beta. So finally the numerator is 3 into alpha plus beta divided by, here we have 2 into alpha plus beta the whole square minus 4 alpha beta plus 5 alpha beta is plus alpha into beta. Minus 4 alpha beta plus 5 alpha beta is alpha into beta. Now we have this expression is in terms of only alpha plus beta and alpha beta. Substitute the values of alpha plus beta is equal to 3 and alpha beta is equal to minus 2. That's equal to 3 into 3 divided by 2 into alpha plus beta is again 3 square plus alpha beta is minus 2 is equal to 3 into 3 9, 3 square is 9, 2 into 9 18 plus minus 2. 18 plus minus 2 is 16, that is 9 by 16. That is the sum of the zeros is 9 by 16. Now we go for the product of the zeros. Product of the zeros P is given by multiplying these two. That is 1 by 2 alpha plus beta into 1 by 2 beta plus alpha. 1 into 1, 1 divided by. You know that already we have here the denominator is 2 alpha plus beta into 2 beta plus alpha. So here the result of multiplication of 2 alpha plus beta into 2 beta plus alpha is same as that of this calculation. So the answer is 1 by 16. So we have the sum of the zeros is equal to 9 by 16. And the product of the zeros is equal to 1 by 16. So you know how to write the quadratic polynomial. Therefore, quadratic polynomial is given by k into x square minus sx plus p, which is equal to k into x square minus. What is the sum of the zeros here? 9 by 16x plus. What is the product of the zeros? That is 1 by 16. So this is the required polynomial. That is, if alpha and beta are the zeros of the quadratic polynomial, f of x is equal to x square minus 3x minus 2, then the polynomial whose zeros are 1 by 2 alpha plus beta, and 1 by 2 beta plus alpha is k into x square minus 9 by 16x plus 1 by 16, where k is any real number. K can be given any real number. So this is the required polynomial.